What's really protecting your company's data when it travels across the internet? Most businesses think they're safe with a basic VPN, but here's the shocking truth. Without proper PPP configuration and IPsec security, your sensitive information could be wide open to hackers. In this video, I'll reveal the 4 critical security features every VPN must have and how to set them up properly. Stick around. This could save your network from disaster. Summarize WAN and VPN. In this course, we're going to talk about the PPP WAN protocol. PPP stand for point-to-point protocol. Remember, WAN protocols work on the physical layer and the data link layer. PPP works on the data link layer, which has been divided into 2 parts. ON at ASC and LCP. LCP is responsible for setting up the link. And NCP makes sure that we can send various IP protocols over this link. For example, IPv6 or even CDP. There are 2 authentication protocols for PPP. We have the PAP, which is an authentication without encryption. That is to say, passwords circulate in clear text on the network. And we have CHAP, which has encrypted authentication. It is therefore better to use the CHAP protocol. Now let's move on to the configuration. We declare our IPs on the interfaces, and we activate the PPP protocol with the encapsulation PPP command. The protocol must be identical on both sides of the serial link. For a PAP authentication, you must first have configured a username with password, as if it were the other router that came to connect. Then, you have to specify that you are using PAP authentication with the command PPP authentication PAP. And finally, you tell it to present itself with the identifier that will have been configured on the other router. For the CHAP protocol, it's the same principle, except that here, it is mandatory that the password matches on both routers. And in this mode, the router will show up with its host name. PPP Multilink. Among the new features of the latest version of the CCNA is the PPP Serial Link Aggregation Configuration, more commonly known as PPP Multilink. Like an Ether channel over Ethernet, the PPP Multilink allows you to virtually combine several links into a single virtual interface. This also allows you to increase bandwidth and have redundancy on your link. On the configuration side, we first create the multi-link virtual interface, and then we configure the serial interfaces to be integrated into the group. Of course, the multi-link group number must match in the configuration of the interfaces. In the previous courses, we have seen the different WAN protocols that can be used with dedicated and private lines, rented from service providers. This type of connection comes at a very high cost, which is why we'll see how to use the internet to connect different sites. The main advantage of using the internet is that it is much cheaper than a dedicated line. After the disadvantage, it is that internet is a public network, and therefore, we have no idea who could spy on our data. That's where VPN comes in. It makes a public network, such as the internet, as secure as a private line by providing 4 elements. We have confidentiality. This means that no one will be able to read the data you send because you can encrypt the traffic. We have authentication, which makes sure that the sender of the data is a legitimate device. For example, by setting up a password authentication method. We have integrity, which guarantees that no one has modified our data. For example, if you've already downloaded an ISO file, you may have seen some websites specify an MD5 or SHA-256 hash. This allows you to check that nothing has been changed between the ISO on the site and the one you just downloaded. And we have the anti-replay, which prevents malicious people from copying certain packets to send them later in order to try to usurp identities. On our topology, we can see what a VPN looks like. On our left, we have a host that communicates with a file server via the internet. We will see step by step the path of a package from the host to the file server. The PC on the left will therefore create an IP packet with its own IP as its source address and, as a destination, the IP of the file server. This packet is sent to the default gateway, which is router 1. Then the router will encrypt the packet and add a VPN header. This new data will then be placed in a new IP packet with the source address of the public IP of router 1 and the destination of the public IP of router 2. And finally, router 2 will examine the VPN header and decrypt the IP packet. It will then be transmitted to the file server like a normal package. The act of putting one IP packet into another is called tunneling. In our example, we have a VPN tunnel between our two routers. More and more, many people are working from home, using client VPN software on their laptop, smartphone, or tablet to create a secure connection with their company's network. Using a VPN and the internet is inexpensive, secure, and also very scalable. It is easier to get an ADSL or fiber line than a private one. There are a number of different protocols that one can use to create a VPN. One of the most common methods of creating a VPN is IPsec. IPsec is not a protocol, but a security that has been added for the network layer. Because the IP protocol has nothing that can authenticate or encrypt IP packets, or even verify their integrity. When configuring IPsec, you can choose between multiple encryption protocols. The most common are the MD5 and SHA. And we also have several authentication options, for example, passwords or certificates. Another popular VPN method is the SSL VPN. When you browse the web, most sites are in HTTPS, which uses SSL. So for the CCNA, there is no need to know the configuration of an IPsec or SSL VPN because it is a specification and there is a security course to deepen the subject. On the other hand, you need to know how to set up a tunnel, but without the security details, such as encryption, authentication, or data integrity.